So yesterday we ended with you guys working on SF2. So Anthony, please read me step number 1. Jacob R., read me step number 1. All right, so who are the two that are present? All right, Jacob R., how many sulfurs are present? And how many F's? 2, thank you. Okay, Jonah, please read me number 2, please, sir. All right, everybody, there's a periodic table underneath your desk you're definitely going to need. Yes, ma'am. Find it. It's on the back, out to the left. I know there's, or you can cram it in the little box that says SF2. Jacob, will you just kind of show her what you did so she kind of has an idea of how you did it? All right. Mr. Jonah, how many does sulfur have, please, sir? Thank you, sir. And what about fluorine? Thank you, sir. All right, Oscar, were you here? You weren't here yesterday, right? You okay? So, can you help me do read step 3, please? All right. So, help me do some math. What's 1 times 6? 6. Oscar, what's 2 times 7? 14. What is 14 plus 6? Why don't I just write 6 again? That is 20. Thank you, sir. All right. Please read 3A, Oscar. Pause. Is that thing charged, everyone? How can you tell it's not charged? There's no positive or negative. Look at SF2. Is there a positive or negative anywhere on it? So it's not charged. Okay, Oscar, please read 3B.
Are you sure it's not an odd?
It's 20 odd. So we're good to go. All right, Jacob N., please read me number 4. All right, so what do I do with that? How do I do that? Determine who's in the center. So, Jacob, who's in the center? S or F? S. What's one reason why? Use the 2 that are given to you in the parentheses. Okay. Or is S less electronegative than F? Who's the most electronegative? So S has to be less than, right? All right. Now, Colin, next one, please, sir. All right, so here's important. How many atoms do I have to hook up to S? 2. Do those F's want to be as far apart or as close together? Far apart. So again, I'm going to ask a dumb question. Is that as far apart? No. Is that as far apart? But we don't like drawing vertical, right? How do we want to draw? Horizontal. So let's draw it side to side. Yep. Now, Colin, read 5A, please.
Subtract the number of bonded electrons from the total number of electrons already calculated.
All right, Colin, what's my total number already calculated?
20.
20. How many am I going to subtract? Why am I subtracting 4 and not 2? Each line is 2 electrons. So, Colin, what's 20 minus 4? 16. All right, everybody good so far? No. All right, and keep going. I'm not trying to be rude, but I got to keep going. Okay, you got to pick up. All right, Carolyn, what's the next step, please, ma'am? 6. It would be nice if I actually added the F's, right? So I apologize. So now I've got to give F's a full octet. So Carolyn, how many does each F currently have? Why? What is one line? 1 bond, but it's how many electrons? 2 electrons. So do you agree each F has 2 electrons? So if it wants 8 and has 2, how many more do I need to give it? If it needs 8 and has 2, how many more does it need? 6. So we're going to give each F 6 electrons. All right. How many total dots did I just use? 12. So what is 16 minus 12, everyone? 4. All right. So I've got 4 left. Ayana, please read me step number 7. All right. This is when things get a little weird because you've got to know your rules and you've got to pay attention here. Those electron pairs want to get as close together or as far apart as possible. Far apart, sir. So those electrons want to be close together as far apart. Far apart as possible, right? All right, so how many did I just use? So am I out? I don't have any extras. I'm done. Trent, I'm going to skip you. Gavin, please read me step number 8. Or 8 total, right? Let's pause and look. Does sulfur have 8 electrons around it? Why is it 8? Because what does one line represent? 2 electrons. So do I even need to worry about this step? Nope, we're going to skip it. All right, Lily, coming to you. This is number 9. Please read number 9. All right, so let's pull out your best for theory sheet. So what we need to determine here is how many atoms are bonded to S. 2. So it's AB2. Are there any electron pairs on sulfur? How many pairs are there? So it's AB2, E2. Now, on your Vesper theory sheet, it's not beads, it's what letter? X. So find AX2, E2. What is the name of that shape? Bend. So that should be the name of the shape you have in this molecule. Now, here's where the problem comes in. Look up there on the board. Is that bent? It is not bent. So look at this molecule in my hand. How can I turn this thing into that thing? Take out 2. Now, is it bent? Yes. So can you leave it like that? You just told me this shape is what shape? That's not bent, so we got to bend it. How do we bend it? We got to take the F's and do what with them? Push them down. So this is the shape you need to have drawn for this molecule. Now, and I always get this question. Do I have to have the dots around the F? Yes. And the reason why is because, go back to the original math. How many total electrons did you calculate? 20. If you leave those dots off around the F, would you have 20 total electrons? You wouldn't. You'd be short. So you can't leave them off. Yes, sir?
How come one of the one electron pairs have to be like top?
Great question. I'm glad you asked that. So I'm going to do what he just asked. So what you're asking me is, why does it not look like that, correct? Technically, I can't count that wrong. However, sometimes symmetry makes things aesthetically more pleasing. To me, that looks fun. That looks crowded. So if you take it and put them up like antenna, aesthetically it looks better. But I can't count that wrong. Remember how we were talking about scientific notation? You can write the same number 2 different ways. You can draw this that way, and I can't count it wrong, but it's not as aesthetically pleasing as others. Okay? Good point. I'm glad you asked. And sometimes I try to slip stuff like that by you guys, so you don't realize it. But there are some gray areas with some of the things that I do. I just don't tell you. Okay? All right. Any questions back on this? So we didn't do one more thing. What's the bond angle? 104.5. Now again, I told you this yesterday, and I'm lying to you. Lying to you. But for this class, you can accept it as the truth, but know that it's really a lie. Does this molecule have an extra pair on the center? Yes. Then it is polar. Okay? Again, I'm telling you that's a lie. It's not always the truth, but for this class, you can just take it as a trick, as a tip. So this is polar. If there is an E in this class, for most molecules, and I may throw one at you that's going to spin that up on its tail, and you're actually going to see the truth in it. But just for anything on the test purposes, E's make it polar. Great question. Do you agree that this is that shape? So everyone look at this, because I think this will help. Is this that shape? So if those F's are to pull that black one down at angles, will those forces cancel each other out? Will they?
Yes.
Will they?
No.
No, they're not going to cancel each other out. So if they don't cancel, because this is going at this angle, this is going at this angle, and they're just going to be battling back and forth and tipping over, right? Okay, so it's not going to be a balanced force. Right? Have you ever been in a boat? It's real rocky, it bounces back and forth. That's not balanced, right? So because this would be rocking back and forth, it would be a polar molecule. Let me show you another way. I'm going to erase this. Okay? So do you agree that we're sharing those? Actually, let me do this. Clear and clear. Let me draw this again. Here. It's wrong color. Nope. Yep. Okay. Are these electrons being shared? Is one of these elements more electronegative than the other? Fluorine is more electronegative. So is this occurring? But then is this occurring? Right? Is the same thing occurring on the other side? So this is here. So this wraps, and then all of a sudden it starts looking like this, right? So do those things in a plane cancel each other off? No. So it's a polar molecule. That's why I told you the trick, the hint. In this class, if it has an E, if it has an extra pair on the central, it's polar. Yes, if it has a lone pair on the central, for this class, it's polar. But again, I'm lying to you, that's not always true. But I'm not going to give you anything in the case that that's not true. All right, Oscar, you had a question. Not in this case. And the reason why, now again, this is not the right shape, but I can still do it on this. When do you use double bonds is when this does not have its octet. Does S have its octet? 2, 4, 6, 8.
Oh, okay. So if it doesn't go to like 8, it doesn't have to get octet, then you have to make it.
Correct, and we're going to see one of those today. And matter of fact, you're going to see one in just a minute. Okay? All right, so let me go back to this, here. So the next one you guys had to do was CH3Cl, correct? All right. Mackenzie, please read number 1 for me, please, ma'am. All right, how many carbons are there? That's okay. How many hydrogens are there? And how many chlorines are there? Okay. Katerina, read number 2 for me, please. All right, how many valence does carbon have? 4. Hydrogen and chlorine. All right. Before I go any further, does everyone know how I get those orange numbers? Who does not know how to get those orange numbers? They're from the group number, right? All right. Gina, next. All right, help me do some math. What's 1 times 4? 4. What's 3 times 1? What's 1 times 7? Add them all up. Everybody cool with that? Read 3A for me, Gina. Pause. Is it charged? How can you tell it's not charged? There's no positive or negative. You're going to see one of those today. Read 3B. It's 14 odd. Let's rock and roll. Okay? All right. So, Antonio, next one, please, sir. What do you do? Keep reading. All right. This is important. Is this one easy to know who the center is?
Yes.
Why? Carbon is always in the center. And who's never in the center? Hydrogen. So we got to throw carbon in the middle. All right. Next, Jamia, please read 5. All right. This is a difficult question because you have to think through it, but hopefully it makes sense. Jamia, how many total atoms am I hooking up to carbon? 4. Very good. Who are they? 3 hydrogen and 1 chlorine, right? So do you agree that I've got 4 things I've got to hook up to it? When I do 4 of them, do they want to be as close together or as far apart? Now, at this point, you should be able to look at me and say, that's not right. Why? Because that's what dimension? 2D, how do we draw? 3D. So when I take my arms out, instead of it being 90, what do I do with them? Bend them down. Now the reason I'm bending them down, am I bending them straight down? No, I'm bending them down and back. Now again, why is it back? Because what dimension are we in? 3D. So I'm going to take these 2 side arms and I'm going to bend them down. So in your mind, what do you have to picture with a line that's going straight down? It's actually coming out at you. Okay? The next question I always get, does it matter where chlorine goes? Not at all. You can put it in any one of the 4 locations. However, because it's one, Antonio, this gets back to the point I said earlier, aesthetically, where's it going to look the best? At the top. But do you have to put it up there? No. Now somebody did this in 3rd block yesterday. They took this thing and they laid it on its side, so chlorine was poking out this way, and then it had like 3 legs shooting out to the left. Is that still appropriate? Absolutely. It doesn't matter. Sometimes there's just a better aesthetic to it. Okay? All right. So, Tony, please read me 5A. What's my total number? How many do I subtract? Why is it not 4? Perfect. So what is 14 minus 8, everyone? 6. All right. Wait, did I go backwards? My bad. Destiny, please read me 6. A what? Please read 6. Keep reading. 2 more words. So, I've got 6 left. Who's not getting any of these 6? None of the hydrogens. So who has to get all 6 of these? Chlorine. Now, the other component to this is, how did I know that chlorine needed 6 more? It needs 8. It had how many? 2. Well, what's 6 plus 2? There's your 8. Yes, sir. And boron. Okay. So did I just run out of electrons? All right, Brandon, I'll back up here to you. I'm going to let you read this one, okay? Read step number 7. It's the little half sheet. All right, hang on. Do I have any left? I'm out, right? So is there any to give to carbon? So I can't even do this step. So I just got to skip it. All right, Anthony, read number 8, please. Pause. Does carbon have its 8 valence electrons as it needs? So do I need to worry about this step? It's skip it. Jacob R., please read number 9. All right. So here's what we got to do. Now let's go back to the sheet. Let's fill out the 2nd, 3rd column. How many atoms are bonded to the central? 4. So that should be in the 1st column. How many extra electron pairs or unshared pairs are on the central atom? 0. So what is the AB model for this thing? AB4. All right. Now use your best for theory sheet and find AX4. Remember, X and B mean the exact same thing. So when you find AX4, what is the name of that shape? Tetrahedral. Is that the correct shape for tetrahedral? Yes. The next one, what is the bond angle? 109.5. That makes sense. Then the last one, and probably the one you have to kind of pause on. Polar or non-polar? Polar. It's polar. The reason why is one of those outer atoms more electronegative than carbon? Who? So is it stronger than all those H's? Yes. So what's going to happen is that chlorine's going to beat up the carbon, and it's going to beat up the hydrogen, and it's going to pull these electrons in this direction, So eventually they're all flowing upwards. So does that create a negative N? Yes, so that molecule is polar. Is that okay? Does that make sense? All right, so I want you guys to try on your own the CH2S. I'm warning you, you're going to have to use all of your rules on this one. Be very careful. This one will tell me if you know what you're doing. Before you do, draw the shape, and let me check the shape off before you do the rest of the sheet. So let me check your shape before you do anything else. Do the math, draw your shape. Sir? CH2S. So draw the shape, and let me check it before you do anything else. I think everybody's on the same page with me on this. So it's CH2S, right? So what's our first step? What do we do? Listen, C, H, and S. How many C's? How many H's? How many S's? I know this is a dumb question, but some of you know what I mean. Do you have to get this right?
Yes.
If you get this wrong, you are completely wrong the rest of the way through. Okay, you've got to get this right first. Every step is crucial. Now, I'm going to multiply valence electrons. How many valence electrons does carbon have? 4. Hydrogen, sulfur, sulfur. Thank you. 1 times 4 is 4. 2 times 1 is 2. 1 times 6 is 6. What's that added up? 12. Very good. Now, who's in the center and why? The easy answer. Why? It's always in the center. All right. How many atoms do I have to hook up to this thing? 3. So I've got 3 things I've got to put around carbon. How do I want to separate those 3 things? As far apart as possible. Is this as far apart as possible? No. What do I have to do with my arms? Bend them down. Okay? So 1, 2, 3. I'm going to ask a dumb question and follow the red lines. Is that okay? Again, the red lines. Just look at the reds. Yeah, basically we just laid it on its side, right? But is it still okay? Sure, it doesn't matter how you do it. Okay? All right. Now, the other question is, Antonio, does it matter where the S goes? You can put it in all 3 locations. Aesthetically, where's it probably going to look best? On the top. So S, H, and H. From here, what do I do with the 12? Subtract how much? 6. Why is it 6 and not 3? 1 line is how many electrons? 2. So I've got 6 left. Now I've got to give my outer ones their octet. Who's not getting any of the 6? Hydrogen. So I've got to give all 6 of them to that guy, right? So I'm out. I'm done. How many of you could understand at this point, you put a period, you end your sentence, you go to the next problem. Does it make logical sense why you could end? Because you're out of electrons, right? It looks good. Everybody's happy. Except for 2. Why is carbon not happy in its current state? It doesn't have 8. Well, Lillian, please read me rule number 8. No, it's just 8 total, like 4 pair or 8 total. Keep going. All right, so again, if it's missing some electrons, what do you do with the others out there? You borrow. So if you're carbon and you want to go buy a car, you have no money, where are you going to get the money from? The bank. How many banks in this molecule have money to give you? Just S. Does everyone agree with that? So how much money do you need? How many pairs of electrons do you need to borrow? 2. Now I'm just going to take the ones off the top and I'm going to convert it to a double bond. So that is the correct structure. This is important. Did that move change the shape of the molecule? It didn't. Did it change the bond angle? Nope, it sure did. So now let's finish it up. How many atoms are bonded to C? 3. Are there any extra unshared pair on carbon? So it's 0. So what's your AB model? AB 3. So find AX3 on your VSEPR sheet. And again, why do I keep saying X? It's the same as B. Again, I hate that, but it just is what it is. What is the shape name for AX3? Trigonal planar. Bond angle. 120. This is the tough question. Polar or non-polar? It is polar. The reason why is sulfur more electronegative than the hydrogen? So it's going to pull all those electrons up towards it. Does that make sense? If I swap the S for H, would it then become non-polar? If I swap the S for H, they're all equal. Exactly right. Does that make sense? All right. So here's what I want to do. I know there's one easy one. If you want to go back and do that one, that's fine. But I actually want to give you another sheet, and I want to work a few of these with you. All right, so let's go back to this one. And again, I gave you the little unknown notice, right? Well, let's talk about this. So let's actually read the rules out loud. So I'm going to start with you, Colin.
Of course.
Of course.
Wrong one. Wrong match.
There we go.
List each element and how many of each are present from the formula.
All right. How many P's? How many CLs? All right. Carolyn, what's next? Read step 2, please, ma'am.
Determine the number of valence electrons for each element.
All right. How many valence electrons does P have? It has 5. Why? It's in group 15. What about chlorine? 7. All right. Ayana, read step 3, please.
Determine the total number of hydrogen.
All right. How many does P have? 5. What about chlorine? 21. And everyone, what's 5 plus 21?
26.
26. All right, I got 26 to deal with. Anna, please read 3A.
Remember if it's charged.
Pause. Is this thing charged, everyone? How can you tell it's not charged? There's no positive or negative anywhere, right? All right. Now, read step 3B, please, ma'am.
Make sure it's not off.
Okay, very good. So is 26 odd, everyone? Go ahead. Yes, and we're going to do that one after this one. That's where I was fixing to go. All right, Trinity, I'm going to let you help me out. So number 4 says draw the skeleton structure. Read 4A, please. All right, this is kind of tough, so we have to really focus here. The rule is either it has the most domains or it is least electronegative. Okay? So the way you can look at it is right here. Which, I don't like that. Let's look at the electronegativity because that's going to make it a little more complicated. So of P and Cl, who's less electronegative? P. How can you tell according to the periodic table? It's farthest from whom? F. Does that make sense? Now, what's the other trick you can simply use by looking at the formula? There's 3 Cls. Which one would you put in the middle, right? So who has to go in the middle? P. Now, I'm going to forewarn you. How we're going to draw this is going to change. But I want you to draw it outright and we'll change it at the very end. So I've got how many things I've got to hook up to this P? So how do I want to space my 3 chlorines out?
Up, left, right.
Draw me a peace sign. Everybody okay with that? All right? Gavin, please read 5A for me, please, sir. All right, what's my total number that I've got? How many am I going to subtract from it? Why is it not 3, Gavin? Perfect. So what is 20 minus 6? I mean 26 minus 6? 20. All right, everybody good so far? All right. So, Leland, please read me number 6, please, ma'am. All right. How many does each chlorine currently have? 2. How many do they want? 8. How many are they missing? There we go. So let's give each one of them 6. 2, 4, 6, 8, 10, 12, 14, 16, 18. So what do I do with those 18? Subtract it from who? All right, dun, dun, dun. I've got 2 left. All right, Mackenzie, please read me step number 7. Keep reading. So how many pairs do I put on the P? 1 pair. Now, the question is, where do I put it? Anywhere except don't split the lines. What do I mean? Do not do this. Don't split the lines. Put it somewhere that it is not. You can put it there. Again, obviously I'm not putting all of these. These different colors represent different options. So you can put it in one of those places. I don't care where. Everybody okay with that? So I'm going to reduce it back down to my first option just to make it clear. So that's it. So am I out of electrons? I'm out. So now let's finish the column. How many atoms are bonded? Oh, check. We didn't do the last part. Read step 8, Katerina. Right. Does phosphorus now have its 8? Yes. Because 1 line is 2, 2, 4, 6. Do you count the dots? Yes. So that's 8. Do I need to make a double bond anywhere? No. All right, read 9, Gina. All right, this is the first time you've done one of these. How many atoms are bonded to the central atom? 3. So write 3 in the first column. How many unshared pair are on the central atom? 1. Again, not dots. Unshared pairs. How much is a pair? 2. So there's 1 pair. What is the AB model? AB3, E1. So on your Vesper theory sheet, do you have to write the 1? No, you don't have to. Okay. AB8X3E. Find that shape. What is it? Trigonal pyramidal. Find angle. 107. So here's the problem. Look at the little molecule in my hand. How can I turn this into what's on the board? Take 1 off. Does that look like this? No. So we've got to move this shape around. Here's what we're going to do. This is the correct shape that you're going to have to draw on the test for this molecule. So P, 2 dots on top, Cl, 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 with each one of them having its 3 lone pair. That is the shape that you will draw on the test. You just got to figure out which one it is and what elements are present. Why what? Why can't you leave it how we had it drawn originally? Because it's not drawn according to Vesper rules. Again, you're going to have enough opportunity that it should stick. Okay? I've never ever had an issue with that. Ever. All right, I'm going to go with this. All right, now, the sheet that I just passed out, I apologize. If you'll flip it over, let's do letter D as in dog. What is the formula for D as in dog? BF3. Everybody okay with this? All right, so first rules, list what's there, right? Boron and fluorine. How many borons are there? 1. How many fluorines are there? 3. This is letter D on the back of that sheet I just passed out. How many valence electrons does boron have? How does everyone know it's 3? Group 13. What about fluorine? 7. Now I got to do my math. What's 1 times 3? What's 1 3 times 7? What is 3 plus 21? Is that number okay? Why? It's even. Is BF3 charged? That's what I thought about it. All right. Who am I putting in the middle of this thing? B. Why not F? It's the most electronegative. Or you could say, well, there's 1B and 3Fs, right? Now, the same policies we said on the last one. How do I want to space these Fs from each other? As far apart as possible. Okay? So 1, 2, 3. F, F, F. Only if. So I'm going to go back and say, when do you draw it like this? Only when there's a pair on top. We don't know if that pair's there yet or not, right? We gotta adjust it if that's there. I'll tell you we're not going to do that on this one. So just stay with me. All right, from this point, now I've connected them all up. What do I do with my number 24? How much am I subtracting? Why am I subtracting 6, not 3? 3 bonds is how many electrons? 6. Everybody with me on this? What is 24 minus 6? 18. Everybody okay with that? All right, now, what do I do with those 18? Who do I give them to? Give them to fluorine first, right? Every fluorine currently has how many? 2. How many do they want? 8. How many more do they need? So let's give them 6 apiece. 2, 4, 6, 8, 10, 12, 14, 16, 18. So what did that do to my electrons? I'm out. Now, an alarm should be sounding in your head. What is that alarm? How many does boron have? Total. Around it. It's got 6. How many does it want? Or does it? Gina, read step 8 for me. Be very loud.
If the central atom is not yet surrounded by 4 electron pairs, 8 total except boron.
Except who?
Boron.
Who's in the middle here?
Boron.
Why is boron an exception? It can only have 6. Everybody go down to the very, very, very bottom of the sheet. There's some notes. Someone read me, not the first little bullet, but the first sub-bullet. Exceptions. What are they? What's the first exception? Hydrogen and helium only need. What's the second? Do you see where someone might mess up here and try to throw some double bonds in? Why doesn't this one need double bonds? Because boron can have how many? 6. I would jot that little note down somewhere that this is okay. Why? Because boron can have 6. If that were anyone else but boron, would you have a problem?
Yeah.
What would you do to solve it?
Double bond.
You would double bond. Now, this is the important question. If you're boron and you want to buy a car, how do you get the money?
Okay.
From the bank. Do all of my F's have some money to borrow to give you? So the question is, which bank do you borrow?
They don't have.
That is called resonance. And we're going to see that in just a minute. Okay? All right, everybody go with this one. So I at least want to fill the rest of this part out because you're going to have to do all this. What is the model, the AB model for this? How many atoms are bonded to the center? 3. Are there any extra pair on the central? So it's write AB3. Consult your Vesper theory sheet and find AX3. And what is that shape name? Trigonal. What? Planar. Planar. If you take a pizza and cut it into 3 equal pieces, what are the degrees of all 3? 120. I would, yes. Because the more you do it, the better. Because you got to, on the test, you got to do every single one of those. It's trigonal planar, 120. Now the last part, polar or non-polar. Why is it non-polar?
They're all equal.
They're all equal. Are any one of those F's stronger than the other?
No.
Nope. So does that part make sense? All right. Now, this one is the fun one. Let's drop down to do F. Drop down and let's do F. You should have an alarm after this one.
Negative.
An alarm should be going off in your head at this point. Why is this the first time? This is the first time we've seen one of these. What's wrong with this one? It's charged. So let's figure out what we got to do with this one. Now, the rules, let's follow them as we always do, and we'll take care of it. Everybody go down to the very, very bottom of the sheet, under where it says notes. Colin, please read me the first note that's listed.
It's if a polyatomic, wait, it's if a polyatomic?
Sorry,
If it's a polyatomic.
that's a typo. If it's a polyatomic.
Make sure to draw the molecule in brackets and put the charge on the outside.
So before you do anything, that's the first thing you need to do. Draw the brackets, put the charge on the outside, and draw this thing inside of it. If you draw the structure inside perfect, do you get full credit? No. All ions have to have brackets. Okay?
Are we drawing the structure?
Yes, we're going to draw the structure inside of it. Ma'am? I can't hear you. We're going to draw it. So my point is as soon as you see the charge, go ahead and draw the brackets to the charge and then go back to the steps. Because here's why. What's going to happen is you're going to draw it and you're going to forget to go back and put the brackets. Does that make sense? So if you do it first, you won't forget about it. Okay? All right, so let's just do our rules as always. N and O. How many nitrogens? 1. How many oxygens? All right, now let's do our math. How many valence electrons for nitrogen? 5. How many for oxygen? 6. What is 1 times 5? What is 3 times 6? What is 5 plus 18? Uh-oh. We have a problem.
Why'd you have to put charge in one? Like,
What's the problem? It's odd. So this is the first time you've seen this. So, Antonio, please read me 3A. All right, what he just said is you add for negative and subtract for positive. What is the charge? Negative. So what am I going to do? Add. Now that doesn't make any sense. But why are we doing that? What am I counting? Electrons. What's the charge of an electron? Negative. Well, if the charge is negative, do you have more or less electrons? More. So you got to add. That's the part where students mess up. I'm telling you now, somebody on the test, if you have to do one like this, you're going to subtract one, and it's going to mess everything up. If it's negative, what do? Add. I'm telling you that's a mistake. So I've got to do plus 1 electron gives me a total of how many? Now is the number okay? Yes. Now we just follow our rules. So I have done everything I have to do to solve a polyatomic. Everything else from here on out is the exact same. So the polyatomics are done at step 3. Unless you forget the brackets, and you got to do it at the end. Yes, sir.
So, outside the bracket, there's a negative for each atom.
Great question. So let me just throw this up here at you. Okay, this has nothing to do with what we're well, it does. But if it were phosphate, right? It would be bracket. It would be bracket. It would be 3 minus. I would do all of this work. There would be a number right here, correct? Let me undo this. Make sense? What would I do? I would say plus 3 electrons. Does everyone understand that? The reason I'm adding 3 is because it was that. Now let me show you the opposite. What were to happen if it were NH4 plus? The first thing you do is brackets and a what? A plus sign. Then I do my math, I get a number, and then this time, because it's positive 1, what do? You subtract 1. Does that make sense? So this is what you have, and then you're done. Everything else is straight up normal. Okay? All right, so I'm going to go back to this. So who's going to go in the middle? Nitrogen is going to go in the middle. Everybody okay with that? Now, I'm going to hook nitrogen up to how many oxygens? 3. How are my nitrogens going to be apart from each other? As far as possible. Somebody going to draw a peace sign? Yep. Everybody okay with that? All right, I'm sorry to do this, guys. Please put your phones up. It's almost to the point it's kind of disrespectful. I don't ever say anything about phones. When I look down and over half of you have your phone, your face in your phone, it's kind of rude. Okay? I don't mind y'all having them, but at least while I'm up here, at least give me that respect. So, from 24, what am I going to subtract? Why 6? Why is it not 3? It's 2 bonds. So 24 minus 6 is how much? 18. Now what do I do with those 18? Who do I give them to? All the oxygens. Okay? So 2, 4, 6, 8, 10, 12, 14, 16, 18. So what did that just do? Just got rid of them all. So it's a yes or no. Am I done? What's wrong? Go back and read step 8. Make sure the central atom has how many electrons? Doesn't. So what do? I got a double bond. But again, the question I asked a minute ago is, who am I borrowing the money from? Doesn't matter. This is called what? Resonance. Now, I'm telling you now, this is not going to be on your test. The resonance part. You're not going to have to do a molecule with resonance. But I still want you just this one time to draw this. Because those of you that are considering AP and heading to AP or considering chemistry in college, you may have to do these. And I at least want you to be able to possibly recall that, oh yeah, I did this. So what you actually have to do is actually draw it all 3 times. On your test, you're going to have to do this. No. But what did I do? So let's look at it. What happened in all 3 of them? The double bond just rotated. Now here's where else also students mess up. Now compare each nitrogen-oxygen double bond to the nitrogen-oxygen single bond. How do the oxygens change? Look at the oxygens with the double versus the oxygens with the single. Does that make sense? So what you did where the double bond is you borrowed it and you moved it down to the double bond. So what happens sometimes the students mess up is they do the double bond, but they forget to take it away and they have too many. They'll actually have 10 instead of having 8. So that is how you would actually represent resonance. You guys did not even realize it, but I showed it to you on your PowerPoint packet. There's a molecule that's SO3, sulfur trioxide. There's actually 7 different resonance structures you can draw with that. That actually showed up on the AP exam about 2 years ago, and they took all you have to draw was 1, but they accepted any one of the 7. And the reason why is because, again, I'm just going to show you this, and I want y'all to tell me if this does make sense or not. So this is what one of them is. How many does S now have around it? 2, 4, 6, 8, 10, 12. Why is that okay? What can sulfur have?
It's expanded
Expanded octet. So do you see how this is possible? So for those that have expanded octets, you can actually make them look all crazy. This was an accepted answer for that molecule because it's a true resonance Lewis function. Okay? All right, I want to do one. Actually, I want you guys to try to do H at the very bottom. Now, I'm going to give you a hint. H at the bottom. When you draw, you're going to have to change the shape when you get to step number 9 of the Vesper. I'm going to go ahead and give you that hint. So try letter H. You're going to have to change the shape according to Vesper once you get it drawn. Okay?